So last time we were talking about the halaloalkanes 2, where we discussed this part, that is the 10.6. We discussed this thing, and now we move on to halaloalkanes 3. Now we already started with the reactions where we did this one, that is the aqueous KOH, and we also did the reaction with the hydroxide in alcoholic medium. So what we learned last time was that the haloalkanes in the last video, that the haloalkanes, they can undergo elimination reaction. They can undergo elimination reaction, but that is only in presence of aqueous KOH or in presence of alcoholic KOH, in presence of alcoholic KOH or NaOH. This has already been explained to you. Then the other type of reactions which the haloalkanes can undergo is substitution reactions. And one of the substitution reaction which we studied about and the mechanism also was in presence of aqueous NaOH or KOH. The difference was, we talked about that in the elimination reaction, the OH minus behaves as a base, and an alkene was produced, while in substitution reaction the OH minus behaves as a nucleophile and an alcohol was produced. Now we will move further more of the substitution reactions. We will talk about further substitutions reactions also. So we continue with the substitution reactions in or of haloalkanes. So one of the examples was definitely where which we have talked about is, as an example, is aqueous NaOH or KOH, one of the very important reaction. This we have already done. Now the next one is with aqueous, or you simply say with water. With water. Now whenever you have a reaction with water, it is also called as a hydrolysis reaction. Is also called as a hydrolysis reaction. You will study more about this at an A2 level, that is grade 13. So that what are the different types of hydrolysis reaction and such, so other things related to it. But here I'm focusing on the reaction with water. So we will talk about this we have done. Let's focus on this. So what happens is, if you have a haloalkane, like let us say I have CH3CH2 Br, and you react it with the water, see the way I'm writing water, and you warm it for the reaction to take place. Now what happens is, this and this goes out as HBr, and you end up with an alcohol. So you started with bromoethane and you end up with ethanol. So the Br or the halogen is being replaced with the OH. So the OH over here, the OH minus, actually when it breaks as H plus and OH minus. So this is behaving as a nucleophile. So all those these reactions we are talking about are nucleophilic substitution reactions. For this, we have already talked about the mechanism also, how the OH reacts and what happens. So we have talked about that. This, according to a specification, it is not required, but you can still understand it. You can still understand it. How you can understand it? That is, this is your CH3. If I keep it like this, we know this is partially positive, this is partially negative. The OH minus ion will attack this, being a nucleophile. The Br will take its the electron, because Br is more electronegative. You have the CH3, CH2, OH, and the Br minus then combines with the H plus ion. So you end up with the HBr. So your products are this and this. But the mechanism is not, I'm just trying to explain you that based on the electronegative difference between the carbon and the Br, the carbon is a center for low electron density. So the nucleophile, which is the OH minus, it attacks this, and the Br, being more electronegative, takes away the bond pair or the electron pair, and then it bonds with the H plus. So that is the overall way the reaction is taking place, but you need to talk about only this, the reaction, actual reaction. Then you can also talk about the third type of reaction, nucleophilic substitution reaction, that is with KCN or NaCN. Now again here, the K or the Na, they are spectators ion. So whether in the exam they give you KCN or they give you NaCN, that does not matter. What is important is the Cn minus is a nucleophile. This is your nucleophile. That is an important thing. So remember the bonding will take place through the carbon because it is like this. The nitrogen is already has three bonds together, so the bond has broken from here. Like if it was carbon, it breaks from here. So it is the negative charge is actually on the C, but we write it like this. We write, so it just for the sake of understanding, nothing else. Another important thing is whenever you are using, this is again for unit 3, whenever you are using KCN, HCN, NaCN, these are all toxic. These are all toxic. So when you are doing an experiment related to this, you need to be careful. You need to talk about the risk assessment, whether if some toxic vapors are being released, then you need to do it in the fume cupboard. Otherwise, if you are handling some toxic chemicals, then you need to wear gloves, wear goggles, safe. So basically, risk assessment has to be there when you are dealing with any toxic material. So cyanide is toxic, very, very highly toxic, especially the HCN is very toxic. So over here, the Cn minus is a nucleophile. The reaction will take place in the same way. You have your, let us say CH3, CH2, Cl, and I take, let us say KCN. What happens is the K combines with the Cl, the K combines with the Cl, and you end up with CH3, CH2, Cn. You end up with a CN. We will talk about this, the naming and everything. So this haloalkane is your chloroethane, It contains 2 carbon atoms. But if you look over here, this thing, okay, this is case here also. If you look over here, there are 3 carbon atoms. So the importance of this reaction is that the product has 1 carbon more than the starting substance. So this reaction with actually cyanide is used to increase the number of carbon atoms by 1. Let us suppose in some reaction pathways, you are starting with 2 carbon atoms, but you have to end up with 3 carbon atoms. Let us say you are starting with something which is, let us say chloroethane, but the examiner wants us to prepare, let us say, propanol. So propanol will have 3 carbon atoms. So while you are converting the chloroethane to propanol, you will have to use the CN in between some mechanism. There will be several steps. So in between, you will have to use the CN because CN brings the 1 carbon atoms. And then once it is CN, cyanide can be changed into different forms, alcohol or something. So we will talk about that later on. So the importance of this reaction is that this is used to increase the length of carbon chain by 1 carbon, by 1. That's the important. Now we have got this product CH3, CH2, Cn. So we need to name them. Now, first thing is that this is your functional group over here. This is the functional group over here, the CN. Now, it is named in two different ways. The functional group can be named over here two different ways. One is your IUPAC name, or you can call it as a systematic name. Systematic means according to the rules. So IUPAC is also according to the rules, is the same thing. And the other is the common name. Still, the cyanides, many of the cyanides, while you will be studying, you will find sometimes they are named as cyanide, sometimes they are named as nitriles. So they are named still, both ways they are named. So we will talk about both the things. So when you're talking about the cyanides, in terms of IUPAC naming, they are named as alkane nitrile. So nitrile. So when you see the word nitrile, it is an indication that it is a cyanide. While in the common name, they are called as alkyl cyanide. Now, how do you name this compound? CH3, CH2, CN. Now, an important thing is when you are talking in terms of nitrile, the nitrile word takes care only about the nitrogen. The word nitrile, it is only considering the nitrogen. So how many carbon atoms are there? Now there are 3 carbon atoms. So if there are 3 carbon atoms, an alkane with 3 carbon atoms will be propane, the full name propane, and write nitrile. Finish. That is the name of this compound. So for example, if you had a CH3CN, so there are 2 carbon atoms, so you would have written it as ethane, full ethane, and then add the word nitrile. So the moment you write the word nitrile, it means you are only talking about this. And the ethane talks about the rest of the carbon atom. However, when you are writing the name in terms of cyanide, the cyanide takes care of the whole thing, CN. So now when you will write the name in terms of alkyl has only 2 carbon atoms left. So for 2 carbon atoms, you will write it as ethyl and then CN cyanide. So you see the difference. Here it is propane, here it is ethyl. The reason is the nitrile takes care only of the nitrogen, while the cyanide takes care of the CN as a whole. So this is ethyl cyanide. Same way, the name for this in the common way of naming would be the cyanide will take care of this. So you are left with only 1 carbon atom. So this will be known as a methyl cyanide. So if you get the product, any number of carbon atoms they give you, you can name it accordingly. So important thing is you are dealing with something which is toxic. So you need to be careful with this. That's the first thing. The second thing is this reaction is important because it helps in increasing the number of carbon atoms by 1. The chain is increased by 1. And then you know the naming, how to name it. That's the only thing. Then the next reaction is reaction with ammonia solution. Reaction with ammonia. Now here there are some very important thing. We know ammonia is a gas. So reacting a gas with something which is liquid is means handling it will be difficult because by the time you warm it, the ammonia will escape out. So remember this, ammonia here is not dissolved in water, because if you dissolve in water, then there is a possibility that ammonia, because if you dissolve ammonia in water, what will happen is it will form ammonium hydroxide, and then this OH will start reacting, behaving as a nucleophile and so on. We don't want that to happen. We don't want this to happen. So therefore, what we do is, if they ask you for the reaction conditions, if reaction conditions are required, then what we need to know is that ammonia is to be dissolved in an alcohol. It could be any alcohol. We are just taking it as an alcohol. So that's the first thing. You don't dissolve it in water. You don't dissolve it in water because then the OH minus will start behaving as a nucleophile or a base, and the other reactions, alcohol and alkene, may be formed. We don't want that to happen. We want ammonia to react. We want ammonia to react, so it has to be dissolved in alcohol. But again, the problem is if a little heating, ammonia will escape out from the alcohol. So ammonia may not react at all. So what we do is ammonia is alcoholic ammonia is mixed with haloalkane under pressure in a sealed tube. So the sealed tube is important. So you take a glass tube, you put all the things inside and you seal it. Why will you seal it? Because when you will heat it, the ammonia or the haloalkane, basically the ammonia, haloalkane is also, all organic compounds are volatile. So haloalkane will also escape out, but ammonia at room temperature has to be, its nature is gaseous. So it will leave the alcohol, change into vapors and escape out. So therefore, when you have closed it, it cannot escape out. So the tube needs to be closed, the glass in a sealed tube. So the tube is closed so that ammonia does not escape out without reacting. So without reacting, it should not escape out. Now here also there are two possibilities. Here also there are two possibilities. The reaction condition. One, definitely this way, that you are doing it in a sealed tube in a with ammonia dissolved in alcohol. But this can be done in two different ways. One way is with ammonia in excess. So one of the way to do this reaction is you are taking ammonia in excess, and the other way would be you will be taking with haloalkane in excess. The haloalkane in excess. So let us see what will happen if this condition is met or this. This is common. This is common. This is for both of them, but based on what is required, you will either take ammonia in excess or haloalkane in excess. We need to focus on this more, but we need to know about this also. So let's talk about when ammonia alcoholic in excess. Remember, in sealed tube under pressure, all that thing is still there. So here what happens is you have a CH3CH2, you have a CH3CH2Br plus HNH2. You can see the way I'm writing ammonia. Now here the normal thing, the H and the Br goes away as a HBr, and the CH3CH2 combines with a NH2. When you have this NH2, is the functional group, another functional group that is known as amines. So we will talk about the naming after a while. Amines, and this is a primary amine. So right now, just know it is a primary amine, not more than that. Now, since further reaction of the haloalkane will not take place, but the problem here is that this HBr which is produced, this is acidic. This is an acidic, just like HCl, and this one with NH2 over here, it is similar to ammonia. So this is a basic substance or a base or alkaline, whatever you want to say. So now what happens is further reactions of the products takes place. Not the reactants, but the products. Further reaction of the reactants take place. So in this case, what happens is, the HBr will react with the, I'm writing it this way, NH2, CH2, CH3. Now remember, this being an acid, it will break into H plus and Br minus. This has a lone pair of electron, so the H plus will go over here. Remember, this is according to the concept of Lowry-Bronsted. Base are substances, so this is a base. It accepts H plus. This is a Lowry-Bronsted concept, that bases are proton acceptor. So the amine will accept the H plus. Why the HBr is breaking into H plus and Br minus? Because this is acidic in nature. So you will have the CH3, CH2, NH3 plus. Now since it is plus, the Br minus will come and attach to it. So you will get a salt over here. You will end up with a salt over here. If you want to know its name, you can write down the name. Otherwise, it is not as important. I hope it is clear. So you will have, if you want to know the name, it is called as ethyl because of this. NH3 plus, it is basically, it is like this, ammonium bromide. So I'm getting the name from here. Now instead of one of the H, you have the ethyl over here. So I will call it as ethyl ammonium bromide. So the overall reaction could be written as the overall reaction till now, what we have talked about, the overall reaction can be written as CH3, CH2, Br plus the NH3. You were getting CH3, CH2, NH3 plus Br minus as a salt. Now the other problem over here is, because ammonia is in axis, so what can happen is the further ammonia can react with this part, or there's no need for it. We can just consider it over here like this. Okay, so you have got this as a product, but the problem here is our aim of this reaction is to produce the primary amine. That's the first thing, and that was also the reason why excess of ammonia was taken. Excess of ammonia was used over here. So what happens is, so this is actually we will combine all of this information later on. So what happens is the CH3, CH2, NH3 plus, the Br minus, it reacts further with more of ammonia. And you end up with the primary amine. And you end up with ammonium bromide as a salt. You end up with a bromide. So your actual reaction does not stop over here. It could have stopped over here if more ammonia was not taken. But because the more ammonia was taken, so you end up with this. This is your end. So if you want to write down the whole reaction, if you want to write down the overall reaction, this was just the explanation. This will be more clear when I will explain you the mechanism. This will be more clear. But right now, what is actually happening is that this thing, your salt is being formed as an intermediate. Intermediate is something which is produced during the reaction and it is used up. So you will not see it in the starting, you will not see at the end. It is produced in the reaction and it is used in the reaction. So that is why when you are writing the overall reaction, when you will be writing down the overall reaction, it would be CH3, CH2, Br plus twice ammonia, one in the first step and then in the second step, and you end up with CH3, CH2, NH2 plus ammonium bromide. This is your final overall reaction, where this is your primary amine. Now, how to write down the name of the amines? Primary amine. Amines, they are written as alkane amine. Remove the E, write amine in its place. Like for example, you have CH3, CH2, NH2 formed over here. So there are 2 carbon atoms. So for 2 carbon atoms, you write ethane, remove the E and add the word amine to it. Finish. That's the simple thing. That's the way you write down the name of the primary amine. So the primary amine, how will you know the primary amine? When it is NH2 and it has only one alkyl group. So there are primary, secondary and tertiary also. More details are in grade 13. So I'm not talking about that right now, but this is what we need. Our primary amine is formed. Now let's look at the mechanism. How this primary amine was formed with the reaction. So if we look at the mechanism, because this the reason why I'm explaining you the mechanism for this but not for the cyanide is because the mechanism for the ammonia is required, cyanide is not required. So over here, let us say I had taken this. So this was our haloalkane I had taken. This is partially positive, this is partially negative. I had the ammonia reacting with it. It has a lone pair of electron. It being a nucleophile, it will attack the positive center. The Br is more electronegative. It will take away the electrons. This will change into CH3C. I'm just writing only the part which in expanded form, the one which we needed, and the NH3 comes and joins over here. Now, since carbon was positive, it remains positive over here. So the NH3 gets the positive charge and the Cl minus over here as this. It is similar to, why did I write Cl? Because we have taken over here the Br. So, and the Br is produced. You could take any of the haloalkane, that is not the problem. Instead of Br, you could have taken the Cl. Now, what I had written over here was together. So when it will be in the ionic form, it will be separated out, NH3 plus and Br minus. So this thing is formed as a intermediate. So this is in the first step. And you can easily see the NH3 is attacking the low electron density center. So over here, the ammonia is behaving as a nucleophile. In the second step, what happens is your positive ion is further attacked by second molecule of ammonia. How it is attacking the second molecule? Now this nitrogen being more electronegative than hydrogen, this bond goes to the nitrogen, shifts to the nitrogen. So the hydrogen is now like an H plus because it has lost its electron to the nitrogen. So this goes and compensates for this. So what happens is you end up with CH3, CH2, NH2. So now this whole thing becomes this after removing the hydrogen, and the hydrogen goes with the ammonia, becomes NH4 plus, and because it is plus, the Br minus comes and joins this. So you have the Br minus over here. You have the Br minus over here. So I hope the mechanism is clear. So in the first step, ammonia is behaving as a nucleophile. It kicks away the Br minus separately, joins. In the next step, it loses one of the H plus. It loses one of the H plus to the Br minus, to the ammonia, forming ammonium ion, and then the ammonium ion combines with the Br minus, forming the forming the ammonium bromide. So right now, what we have done is, right now what I have actually explained to you is, in terms of reactions, I have talked about this. I have talked about this. I have talked about alcoholic ammonia, where ammonia is a nucleophile. I have talked about a cyanide, where cyanide ion becomes a nucleophile. Then I have also explained to you that this is an example of increasing the length of carbon chain. Then I have explained you the mechanism of nucleophilic reactions, aqueous ammonia in the previous video, and for this ammonia now. Now the only thing that will be is still to be explained is aqueous silver nitrate in ethanol. So that can be done in next video, where this reaction is actually uh, studied in terms of testing for haloalkanes. Test for haloalkanes. So when I will explain you the test for the haloalkanes, we take care of the AgNO3 in ethanol, something an important thing. It is similar to the reactions of the halide ions, but just one step extra, nothing else.